Good afternoon, everyone. I'm Minjeong Ban. Today, I'm gonna review about the paper that tried to improve reg system for long context question answering. So the title of the paper is a dual perspective retrieval-augmented generation paradigm for long context question answering. This paper accepted on EMNLP 2024 for this year. Let me briefly introduce about some backgrounds. So the long context question answering is a task that reasoning over a long document or multiple documents to answer the questions. These days there are many long context LLMs such as Gemini and GPT-4. However, it has a lost in the middle problem, which is that it is hard to capture the relevant context which is in the middle of the document. You can see the example here, the right side of the picture. The question is that where did the performer of song I'll Say It graduate from? However, the evidence is right in the middle of the document, and the confused document is at the end of the chunk. So the LLM is confused to answer the right answer. So they improve it by reg with fixed length chunking. The chunking is concise inputs and high relevant context to query. However, chunking strategy also disrupts contextual structure and background information in long documents. It misses global information and some chunks contain incomplete information. We can see right on the picture, the chunk has an incomplete information so that LLM cannot output the right answer. And also, low evidence density in long document leads to low retrieval quality. So as a result, low quality chunks with noise confuse LLM. So there are some trials to improve these limitations by advanced reg. The first one is self-reg. Let me explain the system about this reg system. So at first, it generates kind of like a vanilla reg, and then it evaluates initial generation with retrieved chunks through self-reflection tokens. So depends on the evaluation, it performs additional retrieval if it needed, and integrates all previous information to produce optimized final answer. So this self-reg employs self-reflection tokens to facilitate the exploration of global information in a corpus. However, its reliance on the accuracy of reflection tokens may lead to deletion of valid retrieval chunks. The second one is C-reg. It evaluates the question relevance of each chunk individually to explore factual details. And the external knowledge retrieval is conducted based on this relevance. However, it overlooks the connection between the chunks. Let's move on to the related works. The first one is long context LLMs. The limitation of LLMs for long context is that the context window length is limited. And also, when exceeding this window results in performance degradation. So in recent research, they try to scale the limit context length of LLM for long context. So they have two methods. The first one is training or fine-tuning with long context. Usually it has a high performance. However, it also costs high. The second method is non-fine-tuned methods such as attention-based approaches and context compression method. This method allows for plug-and-play and low-cost scaling LLMs. The second related works is Retrieval-Augmented generation. The reg improves the response quality of LLMs with external knowledge. And also it alleviates issues such as outdated knowledge, hallucination, and lack of domain expertise. However, the limitation of reg, that chunking strategy and direct incorporation of chunks lead to incomplete information and noise. So recently, advanced RAG tried to reduce noise by filtering or re-ranking the retrieved chunks. Also, they designed a chunk-free strategy to mitigate semantic loss. Lastly, there are also some research to improve the capabilities of components of RAG by fine-tuning. Fine-tuning retrieval is for better retrieved chunks and generators for personalized outputs. The paper Lima states that fine-tuning LLMs with a limited quantity of high-quality data enhances the performance of LLMs. This state provides strong theoretical basis for fine-tuning multiple components within advanced RAG methods. Finally, let's look on to the long RAG. Let me explain some components of long RAG. It has a hybrid retriever and COT-guided filter, and LLM-augmented information extractor, and finally LLM-augmented generator. So first, they map retrieved chunks to its source text paragraph. And then they input retrieved chunks to COT-guided filter to get factual detail. And then they input mapped paragraphs to LLM-augmented information extractor to get global information. Then finally, they put the factual detail and global information to LLM-augmented generators and get the final answer. They also constructed the fine-tuning data. To improve the instruction following ability of components and learn long context styles, they get high-quality instruction following dataset for supervised fine-tuning. They use ChatGLM3 and multi-hop datasets such as HAPA QA, two-weekly multi-hop QA, and MusicQ and Quasper. The construction pipeline is automated, so it can generate SFT instruction data from any specific domain. And 2,600 samples are enough to fine-tune LLMs. So let me explain the data construction pipeline. First, for data processing, they remove QA pairs with insufficient lengths for learning long context style. These pairs are labeled as PS, which means supporting paragraphs, and PD, which means distracting paragraph is randomly sampled. So the data components are question, supporting and distracting paragraphs, and answers. Also, for long context extractor data, they fine-tune to extract global information for long paragraphs. So they use supported paragraph as effective global information and zero-shot in context learning input to derive golden outputs. For robustness, they evaluate the golden output using an LLM-based self-evaluator. The last one is the prompt of extractor, and the second one is prompt of the self-evaluator for extractor. And for COT guiding data and filtering data, they generate guiding COT by LLM to review the semantic relations and factual details in supported paragraph. And then they evaluate the COT output for its reliability as golden data using a self-evaluator. And for filtering stage, they combine the query and paragraphs which contain supporting paragraph and extracting paragraph, and guiding COT to form the goal data for training. So they train to output true for supported chunks and false for distracting chunks. And the picture on the down slide is also the prompts for COT guide and the self-evaluator. So let's look at the main core components of long RAG. The first one is hybrid retriever. So the chunk strategy is that they divide long context paragraphs P into chunks. and they impose a minimum length limit on chunks, and sentence is the smallest division unit. They also employ sliding window to extend the context by adding overlapping content. And they inspired by Retrieval. They use dual encoder structure to rapid retrieval at a coarse grain level, and then they use cross encoder to capture deep semantic interaction for further retrieval at a fine grain level. The second component is LLM Augmented Information Extractor. The motivation of this component is in long context QA with low evidence density. The evidence is scattered across multiple locations. And also the evidence also contains logical and sequential connection among chunks. However, the retrieved chunks truncated by fixed windows are disordered and struggle to carry global information. That's why they add the extractor. So we can see how they operate in the system. The first, they mapping the chunks to their source long context paragraphs. When multiple chunks map to the same paragraph, they keep only the one linked paragraph. And then they concat the K paragraphs and fit them into information extractor for zero-shot in context learning. And then they can get the global information, which they set IG. And the other component is COT guided filter. The motivation of this component is that retrieved chunks not always assist generation, especially in long context with low density evidence. And also, the chunk usually contains substantial redundancy. So for COT guide filter in initial stage, they generate a COT with global perspective based on retrieval semantic space, which means they just generate COT with question and retrieve chunks. And for filtering stage, COT serve as global clues, guiding LLM step by step to focus on relevant knowledge, so that the filter judge the relevance between question and chunks. So they output true or false. And then they can get factual details. So they can get reliable relevance levels for question chunk pairs to filter relevant chunks. It helps the system in inferring multi-hop semantic association and in examining available factual details. And lastly, they generate with global information and factual detail information with generator. The global information implies the background and structure information with a long context corpus. And the factual detail information implies filter chunk set with minimal noise and crucial evidence details. Let's look onto the experiment. They use multi-hop data sets and evaluate with F1 score. They use long context LLM methods, advanced RAG, and vanilla RAG as a baseline. So this is the result of the experiment. We can see that the long RAG outperforms other baselines such as long context LLMs and advanced RAG and vanilla RAG. And also, this one is the long RAG with fine-tuning small LM, and the downside is the long RAG with just using LLM, not fine-tuning LMs. So we can see the LLM outperforms the fine-tuning small LMs. So for the reason of the research is that long context LLM often fail to capture fine details. And also vanilla RAG, for vanilla RAG, small chunk disturb the background and structure of long context. And also, small LLMs struggles with long context in context learning and in processing complex information. And also, they did ablation study to prove performance enhancements by extractor and filter. So this is just red baseline, and this is mapping the chunk to paragraph, and they add extractor and they add filter, and they add extractor and filter both. Then we can see when they add extractor and filter, the performance is getting improving. So in conclusion, effective and robust RAG system for SEQA task. So they address two main issues: the incomplete collection of long context information and the difficulty in precisely identifying factual information among self-sensor noise. And the plug-and-play components with small parameter size LLMs can replace expensive API with low cost. Also, they provide an automated pipeline for fine-tuning instruction data construction, so they can facilitate the application of long RAG to other specific domain data. However, they don't have any interaction between core components and retrieval. Also, they can have data annotation bias, which can impair the context understanding across diverse tasks and domain. Thank you for listening. If you have any question, please ask me.